What's that? Yeah, we're good. So we're looking at two ideas today, the difference between a rate of change and a slope. I had to have some confidence that you know something about one of these. What that exactly is, well, maybe we'll find that out here momentarily. Um, but that's kind of what we're looking at today. This looks long, like there's a lot of things we're going to go through. I don't know that it's necessarily going to take the volume of time that it looks like it maybe is going to take. So we're going to skip that for today, though. But our two goals: can we use a rate of change? So first of all, we better define a rate of change, and then secondly, can we find a slope? Do you know anything about either one of those that you're willing to at least say? Sometimes we think, and then as soon as we try to put it in words, it doesn't. It kind of comes out mumbled on us. Okay, we often think rise over run when we talk about slope. Absolutely. Okay, yeah. So a rate of change could be thought of as a ratio. I don't disagree with any of that stuff. All right. Do we have any idea how they're related to each other? You can give it a shot. Yeah, we can definitely could see them both graphically. I would agree with that. Okay, so thinking like a ratio still, is that kind of where you're going? Okay, a fraction. Okay, no, I mean you guys, you're not wrong. We're kind of dancing around it, so to speak. By definition, a rate of change can be identified that way. Essentially, how much do your y values change in relation to how much do your x values change? I put this symbol here because I think you recognize it from science, or should recognize it from science. Does anybody recognize that symbol from science? Do you know what it's called? It starts with a D, if that helps. No, delta. Every D word you could think of there, huh? All right. So delta stands for the change in something. And how do you find the change? You subtract. All right. So maybe will you think of it this way when we say the difference or the subtraction um, in our y values, and then the same would be true here, the difference or the subtraction in our x values. If you want to find the change in something, how many somethings do you have to have? You got to have two, right? You got to have a start point, you got to have an end point in order to determine if there is a change that takes place. Okay. Now, if I give you 3 points, how many rates of change can you have there? Any takers? Jack? No. If we had 2 points, you said there was how many rates of change between them? Like from point A to point B. How many rates of change? You can just one. So if I have 3 points, not 3, you'd have 2. Like if you kind of think about it this way, I could find the rate of change between those two. And then when I'm done, I could find the rate of change between those two. What if you had 5 points? You could have 4. What if you had 10? Okay, so we got it, right? So whatever it is, it's always one less, whatever that would happen to be. So if we come back here for a second and we think about that change in y over that change in x, what's the rate of change there? And this is why I asked you to have a calculator. I mean, you may or may not be able to do that in your head. And either way, it doesn't matter. We just want to make sure we can find the answer. The change in y over the change in x, what do you got? 38 over over 1. All right, Logan originally talked about this idea of a ratio, and so we want to keep that in that sense. So if we're looking at this, right, we're really thinking 152 minus 76 over 4 minus 2. That will reduce all the way down to 38 over 1. What is that 38 over 1 standing for? Do you know? It is, in this case. Good. They're miles per hour. Their speed, right? How fast they're going or how slow they're going. All right. If we look at these two, what is it here? Aiden, what'd you say? Same thing, right? If I did 228 minus 152 over 6 minus 4, it appears as though I'll still end up with 38 over 1. So even though there's 2 rates of change here, there's actually only 1. Yep, on what? Oh, so we skipped that out. I'm sorry. If you come back here in either one of these, and it doesn't really matter, if you do 228 minus 152, you actually get 76. And 6 minus 4, you get 2. And if you take that and reduce it, you'll get 38 over 1. Sorry. I just bypassed that. I'm sorry. So that will be true in both of them. So did you get a 76? Okay. But now you see where that's coming from? Okay. If you graphed those 3 points, what would you get? What do you think? How do you know that? They're all what? Okay, they're all equivalent to each other, so it would be a straight line because they're equivalent. What do you think? 76. Yeah. So we're following that same path. Okay. Ah. Now, we're throwing this word in there. Is it fair to use it at this point? Yes, you think so? Try this. Well, first of all, if your rates of change were not the same, graphically, what would it look like? Wavy. Maybe. It would not be what? It wouldn't be straight. Okay. So looking at this picture here, how many ordered pairs are there? 3. So how many rates of change? 2. Are they different? How do you know that? Okay, they're not the same, right? They're not linear. That's a great way of putting it. So do me a favor, girls. What is the rate of change from this point here to that point there? So that little distance right there. And then guys, I'd ask you the same thing. What's the rate of change from this middle point to that end point? See if you can take a second. These values in the top, they are not ordered pairs. Okay. That is a Y value of 7. That's 8.9. That's 12.1. Okay. So your X value, and those are your Y values. Take a second and see if you can tell me what the rate of change is in either the yellow or the green. What's up? You have an answer or a question? You're confused? Okay. So if you're going to find that rate of change, so we define it like this, what we're really saying is subtract those Y values from each other. And then do the same with the X's. So if you're going to look at that yellow one, what are the Y values in the yellow one? And the other one? Perfect. So do that. So do 8.9 minus 7. And then we're also going to subtract the X values from each other. So what are the X values? That's terrible handwriting. Look down. Okay. So we could safely just call that 4 minus 2. I mean, we don't really need to write 2004 and 2002. Okay. So how about the yellow one? Like, what is this rate of change there? Quinn, you got it? 1.9 over what? Okay, so if we did 8.9 minus 7, we would get 1.9 over 2. Did anybody have 0.95 over 1? Did any of your girls go that far? Okay. Remember, we're talking about the number of passports that are sold. So in millions, what does 0.95 stand for if you're talking about millions of passports? Aiden? Good. So basically what we're saying is we're doing 950,000 a year. That's kind of what we're saying there. Should my answer for the green one be bigger or smaller than 0.95 over 1? Should be bigger. The line is steeper. So do you have it? What do you have? Okay, so 12.1 minus 8.9 originally gave you what? 3.2 over 2, which you reduced to 1.6 over 1. And what does that stand for? That stands for 1.6 million, all right, or 1,600,000, okay? So let's go back to these two for a second. One of these two examples is a rate of change. One of them is a slope. Because no, you are correct. This one here represents a rate of change, or excuse me, a slope. While the second one would be more accurately defined simply as a rate of change. Okay, so you're trying to tell me because one's in table form and one's in graph form? Well, I mean that is an accurate statement, but that is not our difference. No. We did the same thing in both, did we not? We took a y value, we subtracted it from another y value, and then we took an x value and we subtracted it from another x value. We did the same thing in both. They looked different because one was a table and one was a graph. Look at your results here versus your results there. Why would this one here be called a slope? Jack? Okay. And what produced the fact that it was going to be a straight line? There you go. So in order to have a slope, your rate of change, you must have, so we could write this as the definition might be a constant rate of change. Graphically speaking, it has to look like what? If I was to draw a picture, it's got to be a straight line. All right, or what we might say linear. Okay, so we find these two things exactly the same way. If it's the same thing every single time, then we define it with the word slope. If we don't have the same thing every time, then it's just called a rate of change. We understand the difference between those two ideas? So we're just going to look at a couple. So like, for example, in this one here, is that going to be linear? Meaning, is there a slope or is there just a rate of change? Olivia, what do you think? Yes, what? What would that slope be? Good, right? I mean, if you look at the path that's created every single time, right, you can only focus on two at a time. So you would kind of be looking there first. That result is 6 over 1. That result is 6 over 1. That result is 6 over 1. And so therefore, it would have a slope. It would be a straight line. All right. And that's kind of what this is saying here. And we just had a definition of that. Like, if it's the same, we use the word slope. All right. So what about this one? Is there a rate of change or is there a slope? There's got to be one or the other. There are ordered pairs, they would plot. The question is, how do they plot? Straight or not? What do you think? What makes you say that? Oh, hold on. Not 5 over 2, 2 over 5. Remember, you're changing y over your change in x. So that result there is 2 over 5, right? That one's 2 over 5. That one's 2 over 5. So yes. Okay. Change in y over change in x. What about that one? Andrea? It's not the same every time? Okay. If you look at the first rate of change, what's that first rate of change right there? Change in y over change in x. What is it? 4 over 3. But as you move to the next one, do you know what that one is? It is 4 over 6. So immediately right there, it's out, right? What about this one? That one's back to 4. Yeah, yeah. All right. So that one works. Would you be able to tell me what the next ordered pair is? Okay. 18 and 28. Could be. Could be. Good. We don't know what it could be. I mean, we saw a change of 4 over 3, then 4 over 6, then 4 over 3. I mean, maybe the next one's 4 over 6. Maybe it's 10 over 40. I don't know, right? We don't know where that's at. Whereas if we come backwards and I ask you, do you know what the next order pair here would be? And the answer should be the same every time, 10 over 25. Because it did the same thing every single time. It was 2 units on the y and 5 units on the x. Are you all with me on that idea? Okay, so you got to make a differentiation between these two statements. If we say rate of change, we're saying what? What are we ultimately saying? It's not straight. What are you going to say? Good, not linear, meaning the rates of change are going to do what? Could be different, going to vary, not always the same. If we use the word slope, what are we saying? It's going to be a straight line. The rate of change will be consistent or constant every single time. All right. So if we look at something like this and I only tell you 2 points, you don't need more points if the word slope is used. It is an absolute guarantee that they form a straight line. You only have 2 of them, but that word kind of locks it in place. Now, how many of you have seen this before? Okay. All right. What are those little 2s and those little 1s representing? Do you guys remember? Aiden, do you remember? No, you're just getting comfy. My apologies. Yeah. The second, good. The second order pair, and the 1s are simply representing the first order pair, right? So some of you guys, if I asked you to find me the slope between these two, okay, some of you may think like this, x1 and y1 and x2 and y2, and you may write it out. How many of you might take these 2 order pairs and stack them on top of each other and subtract that way? Are we doing the same thing? Yeah. So I don't really think it matters how we visualize this. What is the slope in this situation? Like what's the difference in my y values? Bella, it's a difference of how much? 3, right? Whether you just simply look at the 5 and the 2, or whether you write 5 minus 2, that result is a 3. What's the difference in your x's? Anna? 8. Very good. So here it's 5 minus negative 3, and so that's a difference of 8. If I thought about this in table form, negative 3, 2, 5, 5, can you tell me what the next order pair would have to be? We use the word slope, so there's no misleading. It has to be this. Use that right there to aid you in getting there. Logan, you think you know what it is? You want 8 here and 13 there? 13 here and 8 there. Okay. What's in the numerator? The 3 is representing the change in which value? In y. So you got to be careful. You got to go to the other side. So that is an increase of 3. The denominator is talking about x, and it's an increase in 8. So there you go. Could you give me more points along this path? Sure. And that's why graphically you don't need more than 2 of them. Because if they all fall in a straight line, why are you going to give me 7 of them if 2 of them form what I need? It just doesn't make sense. All right. Try this one, and then we will move into our last idea here. Hopefully your answer matches one of those 4 at the bottom. Hopefully. Tell me about it, right? It's only Wednesday. What's that? You get him with that hard stare down? Do you have an answer yet? Possibly. Does it match one of the ones on the board? No? I agree. That's what I got. Not yet. Remember, you want to look for that change in y over that change in x. Absolutely. Oh, are you hiding it from me? Oh. Is it one of those up there? So if you're going to do the -1, then you have to minus a -3. What happens when you minus a negative? You actually end up adding. Yeah, be careful there. Really? Come on, you gonna play me like that? What's the change in y? How many units did it change, Olivia? Okay, so if you wrote this as -3 minus a -1, that would be a difference of -2 units. Okay, and then your x units. So if we went from -3, yeah, which is -1. 4 minus 5, that's -1. That looks bad right there. And then if we reduce that or clean up the negatives, right, we end up with a result of 2 over 1. How is it that these two statements there are equivalent to each other? True. Think about that graphically for a second. If I just took some random point, let's say I was right there, and I was told to go down -2 over -1. We've all heard the phrase rise over run, right? What does rising a -2 units actually mean? It means to, yeah, but how am I going to do that graphically speaking? I'm going to go down. And if I'm supposed to run -1 unit, that means I'm going to the left. So if I came down 2 and over 1, I don't know, maybe I'm right there. But we said that that was equal to that. If we go back to the beginning, what does rising 2 units look like? Going, rising, up, and then a +1 would say go to the right. So if I came back here and went up 2 and over 1, I might be there. What's true about all of those points? They're all in a straight line, right? So does it really matter which way I go? And the answer would be no. Sometimes it depends on how much space you have on your graph. Maybe you're already at the bottom of your page and you can't go any lower. So you got to think about it in the opposite direction. Side note, you see how nicely that was done? Okay, thank you. Thank you for recognizing that. I mean, that's like, come on. That is like, I'm like throwing darts. All right? Throwing darts here. Now, if you're talking about graphing, you really need to be thinking in one of four ways. Your graphs of slopes can either be positive, they can be negative, they can be a zero, or they can be undefined. Can you generically give me a picture of what any of those may look like? Give me one, Anna. Well, they're all straight. It goes downhill. So from left to right or right to left? We are in the United States. Left to right. All right. So from left to right, that one's going downhill. What else? What just happened?
From left to right.
Yes.
Positive.
Okay. Uphill or downhill? Uphill. I love the fact that you like yelled at me. Thanks. What's a zero slope look like? It is horizontal. Okay. And that means an undefined slope is, no, it's still straight. It's vertical. Okay. Okay. So think about this. Your slope can be defined with this statement here. The change in y over the change in x. Would you agree with that? How much does y change in relation to how much does x change? In a horizontal line, let's just say the 2 points that you're talking about are those two right there. Which one of these two has no change? Is it the y or is it the x? The y. So if I thought about this one here, the horizontal, it would be 0 over, sure, something, right? Some number. There's some amount of change from left to right there. What's 0 divided by anything? 0, which is why this one works out to be a slope of 0. Now, conversely, if you think about the vertical, take 2 points on there. Which one doesn't move now? The x doesn't, which means the fraction would look something like that. When you try to divide by 0, you can't do it. And that's where that idea is coming from. Okay, so it's important to remember that in both of these, you have a 0. It just depends on where the 0 is located. Okay. All right, last problem and we're done for the day. I'm going to give you the answer, right? Here it is. This problem has a slope of 1/2. I'm going to give you one of the ordered pairs that makes that up. My question for you, what's that value right there have to be in order for this to work out? Okay. If you're thinking about this change in y over the change in x, this r is really that value right there. Okay. You think you already have it? I don't know. I mean, if you're brave enough to give me your answer? What do you think? What is it? 4? Okay. Okay. 4? Okay. 4, you just jumping on the train or you actually?
Wait, no.
Changing the answer.
Yeah, because.
What are you changing it to?
It has to be. Because you can't do the 6, the 4 because that you have to do the r first. You have to subtract r minus the 6.
Okay.
To get your answer.
I would agree with that statement. I mean, if you were thinking about this in the form of the slope equation, the change there, you may have something on your paper that looks like, I don't know, 2 minus 3 over r minus 6 is equal to 1/2. Carly, what are you thinking? 8, okay. Logan? 8 as well? All right. Okay. Now, I would 100% agree with you. The answer is 8 if this statement right here was true. Because if that was true, then 8 minus 6 would equal 2, and that would have to be true. But right now, 2 minus 3 is not equal to 1. It's equal to -1. So can you tell me if this is equal to -1, this bottom one actually has to be equal to what? -2, because the two negatives will give you the positive. What number has to be here in order to get an answer of -2? 4. Very good. That number has to be a 4. All right. Okay.
I literally just take the order of pair and I did 6 divided by 3 and then I got 2 and then I did.
Wow, you be careful with that.
4.
It worked here.
Most of the time.
You have one problem to reference. You cannot say most of the time to one problem.
Like my middle school.
All right. Okay. So here's the deal. I don't have another one of these as an example, but I do on your homework. So I'm going to hand you your homework. We're going to do one of them together on your homework to see if that helps the scenario. Okay? All right.